Hello, welcome to Unit F, Lesson 7 Notes. Let's take a look at the first activity. So, this is a quick warm-up. All you have to do is estimate the slope of the line, keeping in mind that these points don't fall exactly on, hence why it's estimation. So go ahead, pause the video, and work through that. All right, let's take a look at the first, at this answer. So, slope, rise over run, but we can also remember that to calculate the slope, it is the change in y over the change in x. Change in y over change in x. So, I know that the points don't fall exactly on the line, but they're fairly close, so I'm going to use these 2 points to estimate my slope. So change in y, that's just going to be 2 minus -6 over 5 minus -4. Now, if you did -6 minus 2 and -4 minus 5, that is fine as well. It doesn't matter the order, just as long as the pair that you put in front, both numbers go in front. So, for example, since I put the 2 first here, I have to put the 5 first as well. 2 minus -6 is just 2 plus 6. And then 5 minus -4 is 5 plus 4. 2 plus 6 is 8. 5 plus 4 is 9. So this slope is approximately 8 over 9. Now, it is approximate. It's not exactly 8 over 9. It's a little less than 8 over 9. Could we have used this point? If there weren't a better option, yes. But by using that point, it's definitely going to not be as exact. So 8/9 is the better, closer slope than what you would get if you had used 8,3. The other thing I want to point out is that it doesn't matter how far apart the numbers are, right? -4, -6, and 8,3 are farther apart, but that doesn't make a difference when it comes to calculating the slope of this line. You want to choose the points that are closer to the line to help you calculate the slope. So that's it for this activity. Let's move on to the next one. So for this next activity, you are going to be describing the linear relationships between 2 variables. You are going to be determining what the trend is and whether or not it appears to be related. So is it a positive trend? Is it a negative trend? Or maybe there's no trend at all. For each description, you are going to use one of these sentence starters where you fill in the blank. So I'm going to give an example of that. I'm going to take a screenshot of a graph and then I'll explain what I mean. So let's take a look at this example first. Here we can see a scatter plot that shows the relationship to be going down, and that would tell us that as the weight in a car increases, the fuel efficiency decreases. So we know that because the line or the data points are indeed going down through the graph. So as, oops, I always forget that, as the weight increases, fuel efficiency decreases. So that is basically what you're going to be talking about. One of the pieces of graphs that you're going to be looking at may have no association as well, so keep that in mind. So go ahead, pause the video, and look at the 3 scatter plots given to you and describe them using those sentence starters. All right, let's take a look at the first data. So this one is comparing mileage to the price of the car. So for this one, we would say it looks like there's a downward trend. So as mileage increases, price decreases. And that makes sense, right? Because we're talking about the mileage on a car. The more miles on a car, the less price it's going to be, because that means the more used it is. All right, the next one, this one seems to have an upward trend. So this one we would say, and it looks like we're talking about the weight in carats. So we're talking about some kind of jewelry, diamond perhaps. So we would say as the weight increases, the price also increases. So you may or may not have known this, but typically diamonds are weighed in what's called carats. So this is talking about a diamond specifically. All right, and that makes sense, right? The bigger the diamond, the more expensive it's going to be. All right, next one. All right, for the next one, also kind of shows an upward movement happening here. Not as obvious as the previous one, but enough that we can still say that there does seem to be some kind of association happening here. So for this one, I would say as the temperature increases, energy consumption also increases. Now, this one's also not very surprising that as temperature increases, energy consumption also increases, because as it gets more hot outside, we're going to be running our air conditioning more. So especially in this area right here, you're definitely going to want to have the air conditioning on. So the other points might be farther away from what would be considered a good line of fit, is because some people don't necessarily run their air conditioning when it's in the 80s. Some people do. It just really depends on preference at that point. But once you hit high 80s, most people are definitely going to have their air running. So there are some outliers in this case, but it depends on the person at that point, and what type of energy they're using at home. So although there is an association between the two variables, this is definitely a weaker association than the previous two scatter plots. All right, next activity. Let's move on. Activity 2. For this one, we're going to take a look at the equations that we would use for the model, the linear model, and we're going to look more specifically at the slope and give us a description of what that slope means in terms of the situation. So if we look back at the car problem that we started the previous activity with, the equation for this line would have been y equals negative 0.073x plus 17,404.485. Lots of numbers happening in this one. So this is the equation for the line of best fit for that trend line. And keep in mind that it matches the trend line, not any specific data point. And that sometimes is a little confusing for students. So in this case, we're looking at the slope. So remember, the slope is always the coefficient to the x. So for this line specifically, the slope is negative 0.073. And we're going to describe what the slope means for this situation. Reminder, we always describe slope as x increases by 1, y will either decrease or increase by the slope amount. So, and we don't want to just say x and y, we want to connect it back to the situation. So this situation was talking about mileage and price. So we would say for every, oops, that's not how we spell for. for every additional mile, the price decreases by 7 3/10 of a penny. An odd number to say, but 7 3/10 of a penny. So notice I am talking about both variables, which happens to be mileage and price, and I'm also talking about the slope. It's decreased because my slope was negative. So you are going to do the same thing. You're now given the equations for the 3 scatter plots, and now describe using the slope. Go ahead and describe what it means for the situation. All right, so let's take a look at scatter plot A. My slope is 5,520.619. So for this one, I would say, for every additional carat, the price increases by $5,520, 61 9/10 of a cent. Again, weird dollar amount, but sometimes you can get into partial pennies as well. And that makes sense, right? Diamonds are very expensive. So it would make sense that a carat would increase the price by that amount. You could have even just rounded that to $5,521 if you wanted to. All right, for scatter plot B, my slope is negative 0.011. This time we are talking about weight and fuel efficiency. So we would say for every 1 kilogram, the mileage decreases by negative 0.011 miles per gallon. Okay, and then number 3, my slope is 0.59. This time we're talking about temperature and energy consumption. So we would say for every increase of temperature by 1 degree Fahrenheit, the energy consumption increases by 0.59 kilowatt hour. What's the abbreviation for that? Kilowatt hour. The key thing I want to mention here is that these are all predictions. So it's not a guarantee. When we talk about slope in terms of scatter plots, we are just making predictions. We are not saying for sure that this is going to happen. Also, remember the easiest way to find the slope in any linear model or linear equation is just the coefficient connected to the x variable. And remember the difference between a positive and negative slope means that as x increases, for a positive slope, y will also increase. But for a negative slope, y will decrease. All right, let's move on to the last activity. All right, so for this last activity, you are given 5 scatter plots. For each of the scatter plots, you will need to decide whether it makes sense to fit a linear model to the data. If it does, then decide would the graph be have a positive slope, a negative slope, or a slope of 0. Just keep in mind that sometimes a linear model is not best fit. So there's other things, other type of models that are out there, and sometimes just no model would make sense. So go ahead, pause the video, and answer question 1, and then we'll come back and talk about question number 2. All right, question number 1. Yeah, definitely. A is definitely going to have a linear model. It almost forms a pretty straight line. And this is negative. It's downward, right? It's as x is increasing, y is decreasing. B, I would still, yeah, it's a little bit more spread out, but it still tends to follow a positive trend. So yes, I would still say this is a good linear model. But this time it's going to be positive. Number 3, still a little bit more spread out, but still does have a downward trend. So yes, and this time it's going to be negative. For D, this one's a little hard. It's kind of has a little bit of an upward, then a downward, and then it stabilizes. So for this one, it's a no. A linear model would not work. And then for E, although we do have this little outlier right here, for the most part, it is an upward trend. So this would be yes, and it is a positive slope. All right, let's look at question 2. Last question. So question 2, it says, which of these scatter plots show evidence of a positive association between the variables, and which ones appear to have a negative association, and which one appears to have no association? So for this, we would just use that idea of a linear model versus not. So for this one, this first one is going to be a negative association. Just like our slope is negative, the association is negative. They are connected to one another. For B, this one would be a positive association. For C, this one would be, you guessed, a negative association. And then D, this one's no association. If you cannot put a linear model to it, then there's no association. And then the last one is also going to be positive. So the key thing that I want to point out for this lesson is that to determine if they're a linear model, if data has a linear model, you're looking to see if they follow a trend. Okay, do they does the data follow a trend? You could have outliers, but for the most part, there should be an upward trend or a downward trend. Associations are connected to the slope of the graph. So if there's a positive slope for the linear model, then there's a positive association. So negative slope, then there's a negative association. No linear model means there's no association, okay? In the same instance, when you have a positive association, that means as x increase, y also increases. And then for negative, as x increases, y is decreasing. Just like with slope, association is the same thing. So that's it for this lesson. Make sure you submit this lesson for points and then get started on the cool down. Thanks for watching.